Okay. What did we learn at the start of the chapter? Law of sines. Law of sines. So, to figure out angle B, we were given 97.3 for that, 40.2 for that, 31.6 for that. So, to figure out angle B, we just subtract from 180. So you take 180 minus 31.6 minus 97.3. What do we get? $50.8. So that's what angle B is. So the length of side A is opposite 31.6. So we say the sine of 31.6 over A equals the sine of two things that we know right at the start. Well, I know C and gamma, so 97.3 over 40.2. Cross multiply and solve. 51.1. All right. 51.2 now. No. 51.1. Quinn. Jeez. It's 31.6. All right. So to find side B, you'd say the sine of 51.1 over B equals the sine of 97.3 over 40.2. And whatever you get when you do those. Okay. Now, when you see a problem like this, I would draw two triangles right away, but do not label them. On the first one, it gives you angle B is 39.2, so 39.2 goes here. B is opposite of that, that's 32.7. A is 39.3. So this would be B, this would be alpha, this would be gamma. So then put them in the same spots in this triangle. 32.7, 39.3, 39.2. Okay, so the first thing we have to find is alpha in each of these triangles. So to do that, we say the sine of alpha over its opposite side, 39.3, equals the sine of beta, which is 39.2, over its opposite side, 32.7. So 39.3 times the sine of 39.2 divided by 32.7. And then once you get that, you get a decimal, and then you go second sine, second answer, inverse sine of the answer. Okay? So when we get that, we get what as a angle? 49.4. So if that's 49.4, its obtuse partner would be 180 minus 49.4, which is 130.6. All right. Then we have to find angle gamma in each. Well, 39.2 plus 49.4 is 88.6. If that's 88.6, then I'm left with 91.4 for this. If we add these two together, that adds up to 169.8, which gives me 10.2 up here. So then we just have to find C in each. To find C, use what you started with. The sine of 39.2 over 32.7 equals the sine of 91.4 over c. And that'll give me c for this one. What do we get for c of that one? $51.7. And then over here, got to do the same thing. Sine of 39.2 over 32.7 equals the sine of, this time it's 10.2 over c. So 32.7 times the sine of 10.2 divided by the sine of 39.2. What does c wind up to be?
I'm doing quotient, right? So it's 2 times the derivative of y, which is just 2, minus 6 times the derivative of y, which is just 2.
No.
Why?
What's the first derivative of anything with a y involved?
dy
dx.
2 dy dx.
So what is c? 9.2. What class do you have now, Ellie? Anything? Oh. But Traxel's gone. Wait, you have a Traxel? Oh. And you didn't tell her? Well, I'm sure somebody told her. Okay. Okay. So for this one, instead of drawing two triangles right away, I see right off the bat I have an obtuse angle. So if I have an obtuse angle at the start, how many triangles at most can there be? One. So if this is 136.5 and it's gamma, C is opposite of that is 5.9, and A is 9.2. So if we put alpha there, A is 9.2. What do we got going here? What should we do next? Law of sines? Okay. Or you could just, go, this doesn't look right. What's wrong with this triangle? The longest side is shorter than this side. The obtuse angle has to be opposite the longest side. If it doesn't work, there's no possible solutions. The lunar crater problem. All right. You have points A, B, and C. Don't put C down here by B. C goes above A and should be an obtuse triangle because this is 113 degrees. ACB is 44. ACB is 44. We want to find this side. I'm told that AC is 54 meters apart. Now, I have this side. I want this side. I have the opposite of this side, but I don't have the opposite of this side. So I have to find angle B. How do I find angle B? Add 44 and 113, which is 157. Subtract it from 180, and you get 23. Okay. So the sine of 23 over its opposite side, 54, equals the sine of 44 over its opposite side, x. So it's 54 sine of 44 divided by the sine of 23. 96. Sounds good to me. Okay, when we have A is 23.6, B is 12.4, C is 18.7. This is the law of cosine. So if we want to find angle alpha first, we say, well, a squared equals b squared plus c squared minus 2bc cosine of alpha. So 23.6 squared equals 12.4 squared plus 18.7 squared minus 2 times 12.4 times 18.7 cosine of alpha. If I want to get alpha alone, I take 23.6 squared. So I go on my calculator, I go parenthesis 23.6 squared minus 12.4 squared minus 18.7 squared. And then I divide it by negative 2 times 12.4 times 18.7. And that decimal will give you what the inverse what cosine is equal to. And you take the inverse cosine of the answer and you get an angle. Now I'm thinking that angle might be obtuse. It's awful close to being obtuse. What is it? 96.6. From here, if you wanted to, you could do the law of cosines again and just put b alone on one side and do the exact same thing again and figure out angle b. Or you can use law of sines now. Sine of 96.6 over its opposite side 23.6 equals the sine of beta over 12.4. Cross multiply and solve. So if you cross multiply and solve, what do you get? Anybody have confidence in their answer? I would say 41.5 sounds about right. 31.5 might even sound better than that. So these two add up to 128.1. So then that would be 51.9 for this one. Okay, there we go. If you have side angle side, whoops. Yeah, that was right. Side angle side, life is a little easier. Okay, to find side B, b squared equals a squared plus c squared minus 2ac cosine of beta. So b squared equals 9 squared plus 6 squared minus 2 times 9 times 6 cosine of 99.6. So b squared equals a big number. Bigger than 9 or bigger than 6. But then you have to take the square root of it. So I don't know what b squared equals, but what does b equal? 11.6. Then you can do law of sines from there. Now make sure 4 decimal places. So it's 11.6194. So it's a sine of 99.6 over 11.6194 equals the sine of alpha. Oh, they want sine of gamma over 6. And cross multiply and solve and do this, and then just subtract to find angle A. Okay, if we have 3 sides, you use Heron's formula. What's Heron's formula? Well, you add up the 3 sides, 5.5 plus 8.1 plus 11.6, and take it and divide them all by 2. 5.5 plus 11.6 is 16.1, no, 17.1, plus 8.1 is 25.2, divided by 2. And 25.2 divided by 2, 12.6. So then the area equals the square root of 12.6 times 12.6 minus 5.5 times 12.6 minus 8.1 times 12.6 minus 11.6. And you multiply all those together, take the square root of that answer, and you get the answer. Now, if you have this triangle, you draw it out, and then you can draw it out and label it right away when you're finding an area. So this is 43.5, 62.1, and side C is 11.4. I have angle, side, angle. I need side, angle, side. Okay? So I can use the law of sines to figure this out, but I'm missing side or angle Y or angle gamma. So this is 105.6. 105.6? Yeah. So we're at 74.4. So the sine of 74.4 over 11.4 equals the sine of 62.1 over its opposite side, B. So then we figure it out. And then once you find B, what is B? What did you get, Cole? Oh, okay. What did you get, B, Samantha Troxel? 10.5. And even if it's wrong, we're fine. I just want to make sure you know how to set up the next part. So here we have side, angle, side. Not that you would be wrong. So since we have side, angle, side, we go 1/2 of 10.5 times 11.4 times the sine of 43.5. And then that'll give you the area. Okay? So that's the process. Okay, vectors. This is what we did last time. I guess that was yesterday, wasn't it? Okay? So, vectors. What I would do is I would write out the original vectors. A is 0, 4. B is 2, 0. So what's A plus B going to be? 2, 4. What's A minus B going to be? -2, 4. So A plus B is 2, 4 over 2 up 4. A minus B is -2, 4. Here, A is 1, 4. B is 5, 1. What's A plus B? 6, 5. What's A minus B? -4, 3. So I find 6, 5, which is this one. I find -4, 3, which is this one. Which one has an angle of 30 degrees and is about 4 long? C. Magnitude and direction of this vector. Magnitude. Whoa. Come back here. Okay, the magnitude is the square root of 1 squared plus a -1 squared, which is the square root of 1 plus 1, which is the square root of 2. So our angle, theta, equals the inverse tangent of y over x, but I tell you to just use positives. Inverse tangent of this is like 45 degrees, right? Okay, so that's 45 degrees. Now, I'm in what quadrant here? 4. So if I'm in quadrant 4, that means I'm 45 degrees down from this line. So you take 360 minus 45. If you're in this quadrant, you take 180 plus whatever it is. If you're in this quadrant, it's 180 minus whatever it is. Okay, you always go from a horizontal. You never go from 90 or 270. Okay, you always go from your horizontal. So it's 360 minus 45, which is 315 degrees. The donkey problem, and that's the last problem on here. What I would do is I would make a parallelogram out of this. So here's the donkey. So if this is 25 degrees, what's this angle right here? 155. Then draw the ropes if they were in a straight line. Okay. This is 55. This is 80 because this is 80. So parallelogram opposite sides are congruent. So these are the three numbers, and you use law of cosines. X squared equals 55 squared plus 80 squared minus 2 times 55 times 80 times the cosine of 155. That's what x squared is. So then you just take the square root of your answer, and you should get something around 131-ish. 131.9. Okay? That's what your test is going to be, 13 questions. Now, we just took a quiz on Monday that, besides questions 9 through 13, was much like this. Okay? So, the first part of the chapter is the big stuff. That's the hard stuff. These vectors and the donkey problem, that's no problem. Okay? So, hopefully you understand everything. Test is on Tuesday. Make sure you practice the practice test multiple times before Tuesday.